Okay, so if you see a, or let me go back real quick. So there's 6 signs of a chemical reaction. If you combine 3 and 4, it's really 5, but it'll be 6 if you were to separate those out. So the first sign would be a color change. So if you do a chemical reaction, you see a change in the color, like you see rust forming or you see mold growing, that means a chemical reaction has occurred. The second sign is a formation of a gas. So if you mix 2 things together and you get a bunch of bubbles forming, like this, or you mix vinegar and baking soda together, you get a bunch of bubbles forming. Those bubbles are carbon dioxide. That's a sign that a chemical reaction has occurred. In other words, a chemical reaction, like you have broken bonds and reformed the bonds. You've taken the atoms that were on the left side of that arrow, broken those bonds, and rearranged the atoms like they're a bunch of Lego blocks to form something new. Okay, in this case, it'd be carbon dioxide. Okay. The third would be, and this is kind of lumped underneath temperature or energy change, something called an endothermic reaction. We're going to talk more about endothermic reactions at the very last unit of the year that we do. But basically, an endothermic reaction, we're breaking bonds, and we're using the energy from the environment, the heat from the environment, to break those bonds. And what happens is because we had to use energy from the environment to break those bonds, that's going to make the substance become cooler. So in other words, if you see if you were to put a thermometer in like a beaker that's doing a chemical reaction, and you see the temperature go down on that thermometer, that's a sign that a chemical reaction has occurred. An example would be like cold packs. Have you ever used like a cold pack? Like there are certain ice packs that like you touch them and they're not cold, but then you break some chemicals that are in that cold pack together, that chemical reaction will occur and that pack will get really cold. So that'd be an example of an endothermic reaction. Photosynthesis, that's also an endothermic reaction. A lot of times when you build things together, take smaller things and build them up, those are endothermic reactions. Anyways, we'll talk more about those later on in the year, but that'd be part of temperature change. Exothermic reaction, it's still underneath the umbrella of a temperature change, but in this case, it would be the release of energy. So if you add things together and you get a release of heat, that's going to be a sign that there's an exothermic reaction happening. So in an exothermic reaction, we're actually making new chemical bonds, and the making of those bonds is what's going to cause the release of heat. It's kind of backwards thinking. The making of bonds will release heat, and that's what will cause the temperature of the thermometer to go up. I'll explain more about that later on in the year. Just for now, understand if you mix certain chemicals together in a beaker and you get a raise in temperature, that's a sign a chemical reaction's occurred. So fireworks exploding, all that heat giving off is a sign, in addition to the colors made by the fireworks, that chemical reactions are occurring. This is also the idea of hand warmers. I don't know if you ever used hand warmers, but it's similar to like the cold pack, where if you combine, like you break, there'd be like a little kind of thing inside these packets of hand warmers, where if you break it, it'll combine a bunch of chemicals together that will give off heat. And so that's how you know a chemical reaction has occurred. Okay. And then I think we're at number 4 now. A precipitate has formed. This one's a little less obvious, and it's something I've mentioned before when we went over some of the states of matter. But if you combine 2 liquids and you end up getting a solid forming, so it's something you can see right here, that the formation of that solid is called a precipitate. So a precipitate is that solid. That would be a sign a chemical reaction's occurred. A medical example could be, you ever heard of like gallstones or kidney stones? Those would be examples of precipitates that have occurred because of certain chemical reactions that are happening in the gallbladder or in the kidney, and then those can cause issues because you have these basically like rocks inside your kidney, and that can cause blockages and issues like that. Cheese, what makes the solid parts of cheese, that chemical reaction, the formation of that cheese would be a precipitate. Because I don't know if you notice, cheese is just really coming from the milk of the cows, and then eventually you slowly can solidify the parts of that milk, some of the fat and stuff, to make it form the cheese. So there you go. All right, and then the last one is an odor change. So you're like, man, I smell. Why do I smell? Because there's a bunch of chemical reactions going on with the bacteria on your skin. They're eating, like whenever you sweat, you ever wonder why like sweating makes you smell? So what makes you smell like when you sweat is really bacteria. It's not literally the sweat coming off of you. Like if you shower and you clean all the bacteria off of you and then you sweat after you shower, you're not really gonna smell. I don't know if you ever like try doing that. I mean, eventually you might, but it's not like a good idea. But like what makes you, like when you work out and you start smelling, what's making you smell is the bacteria eating things in your sweat, and then they give off an odor. But that odor is coming from chemical reactions. So bad breath come from like a chemical reaction between the bacteria in your mouth and the food that you ate giving off that bad smell. Or it could be like literally the food you ate just smells bad. It could be something like that. Okay. Any questions about any of these? So a lot of them are kind of common sense. Adam? Yep.
So like when you rub your hands together, like your hands get warm, would that be a chemical reaction?
Oh, that's a good question. No, I mean that'd just be a little bit. That's just like friction. But so I guess that'd be an exception to that. But I'll confirm that. I can't say that 100%, but I think that'd be just something a little bit different. You wouldn't really say, because a chemical reaction, you're saying you're breaking bonds and you're forming new bonds. So when you're doing that, like you're not really breaking bonds. You're just creating this friction from like making the molecules in your hand move around faster. But that's a good question though.